So this is 3.3 in elementary algebra, more on graphing, and it's called intercepts. And I think you'll find this section not only short, but fairly easy. So I'm going to go ahead and put my handy dandy graph on here. And let's look at what an intercept is. An x-intercept is whenever we have a line that crosses, or that we draw here, it will cross the x-axis somewhere. Okay, so this is the x-axis. Notice this one crosses here, this is crosses there. Where it crosses the x-axis is called the x-intercept. Now I bet you can figure out what a y-intercept is. It is, obviously, where that line crosses the x-axis. The purple one crosses there, the blue one crosses there. Alright, and there's a real easy way to figure out where they cross. And the easy way makes it nice because you don't even have to have a graph to figure it out. Okay, so this is the way it works. Let's get rid of this graph, move it out of the way since I said we don't need it. Alright, so we have 3x minus 2y equals 6. And this is example 1. If you're looking for the x-intercept, what you do is you put in a 0 for y. Okay, that's all you do. And you can find the x-intercept. 3x minus 2 times 0 equals 6. 3x, that goes away, equals 6. Divide by 3, x equals 2. That is the x-intercept. That is where, if we have a graph, that is where the graph will cross the x-axis. Okay, if we're interested in finding out, okay, let's get rid of this. If we're interested in finding out what our y-intercept is, where it crosses the y-axis, we put 0 in for x. So we're going to take our same equation there, but this time we're going to put a 0 in for x. That goes away because 3 times 0 is 0. And we get negative 2y equals 6. We divide by negative 2, divide by negative 2, and we get y equals negative 3. So that ends up being our y-intercept. That means y equals negative 3, which is right there. That's where our line is going to cross that axis. So for this equation, what did we say? Our y equals negative 3. We also said that our x equals 2. Now, look real nice and fancy. We have 2 points. We can draw a straight line. Remember, we have to have 3, but if we're only looking for 2, if we plug a 0 in for x and a 0 in for y and graph it, that's what we get. So it's a real quick and easy way to not only find where the graph crosses the x and y axis, but it's also a quick and easy way to graph the equation, taking the chance that you might get it wrong because you didn't find that third point. But it is a pretty slick way of doing it. Alright, so let's look at example 2. Example 2 says negative x plus 2y equals 4. Okay, so to find the x-intercept, we set y equal to 0. Those go away. So we have negative x equals 4. And if we don't like that negative there, we take it off and move it to the other side. So there's my x-intercept, negative 4. So that means on our, on our graph, we go to x equals negative 4 and draw a dot there. Alright, now we're going to find the y-intercept. The y-intercept means that we put 0 in for x. And obviously there's no negative 0, that goes away. And divide by 2, so y equals 2. So I go to my y and I go up 2, and I've got that right there. And I can draw my line there. Okay, so not really too bad. Hopefully you're finding this to be a little bit more refreshing from some of the other stuff you've done that's been a little more difficult. Let's go up to example 3. So we have y equals negative 1/3 x plus 2. All right, so we have to look for the intercepts, both the x-intercept and y. To find the x-intercept, we plug 0 in for y. So we subtract 2 from both sides. That's an equal sign. Negative 2 equals negative 1/3 x. Okay. Now we divide both sides by negative 1/3 x. Remember, I like to make that thicker. Those go away. Okay, so remember we invert and multiply, so negative 2 times negative 3 over 1. Okay, we just took that and turned it upside down. The negative stays there. So now we have negative 2 times negative 3, which is a positive 6. So we graph that. Graph that positive 6. Okay, now what we're going to do is we're going to find the y-intercept. So to find the y-intercept, we put in 0 for x. Which helps because it takes away that fraction right there, and y equals 2. So I put y equals 2 there, and I have a graph. Okay? So that's it. And one of the things that you will find that we do with this is we will write an equation oftentimes that this is a property y-intercept on page 213. The y-intercept of the line y equals any number times x plus any number. This number right here will always be where the graph crosses the y-axis. Always. That's called the slope-intercept form, and we'll get into that later. But if we had an equation such as, notice that this equation looks whoa, I didn't want to do that. This equation looks similar to this. We have a y equals a number, 1/2, times the x, plus another number. In this case, it's a minus 5. This number and its sign is the y-intercept. So if you were going to start graphing this, you're automatically guaranteed one of the points right there at negative 5. Now you only have to find a couple more to draw your line, but you're always given that. So if I gave you y equals 2x plus 1/3, notice y-intercept is right there. Makes it real easy. You just stick it there on the y-axis. If I have y equals 6, notice I don't have an x, but I do have the number that's all by itself, and that is always going to be the y-intercept. The number without a variable is the y-intercept. So the y-intercept of that is 6. Okay? If I had something like, let's do this in black, y equals 4 minus x. Well, this is the number all by itself, so that is going to be the y-intercept. So the y-intercept is 4. Okay? And that's all there is for this lesson. I'm not going to go over any of the problem sets because it's a pretty simple lesson, and I already went over pretty much everything that you need to do. So go ahead and get started with problem set 3.3.